Hi guys, I'm back with another arcade PCB repair. It's yet another Double Dragon board, which I got as non-working. And as usual, we are going to troubleshoot the PCB step by step together and see that we can get the board working again. Okay, so as always, first step is to look at the board and see in what physical condition it actually is. I always check for missing parts, of course, for corrosion, for maybe damaged traces on the board, anything obvious that can later, while troubleshooting the board, help you to determine where the problems are. So on this side, on the CPU board, I don't see anything that could be wrong with it. It's just like with all older PCBs, arcade PCBs, it's just a bit dirty. But that's okay, we can clean it up later if we get the board running again. And the bottom side is always cleaner. Seems to be complete also, but this time we have signs of a previous repair over here. Actually, someone put a jumper wire there, and you can actually see that there might have been a problem with a trace over here. We can actually look under the microscope, I'd say, to see what's going on there. Okay, under the microscope we can see better what's going on. There's actually a trace leading to the IC leg, which has the red jumper wire connected to it. That has been cut because there's something mechanically probably hit the PCB and actually digged into the trace, as you can see here under the microscope, and it has been fixed by putting the jumper wire in, which is of course not what I would have done or what I recommend, because it's actually very easy to just remove the protective green coating on the trace and just put a small drop of solder and maybe a tiny bit of wire on the trace to bridge it again locally. I think that's a much more sophisticated way to solve these problems. So maybe when we get the board back working again, I will remove this this jumper wire here, and we can fix the trace that has been damaged at this spot. But okay, for now let's hook up the board to our test station and see what it does. Okay, I've hooked the board up to my test station. So let's turn it on and see what we get. So white screen. Oh no, there's something going on. Well, that's interesting. This actually might look like the title screen. Okay, now it's gone. There's just two red squares down here. Okay. So I'm not sure if the game's actually running at all. But on the screen we just saw, I thought that it somehow looked like the title screen with the Japanese writings on it. Okay, so this, I think, is the high score table actually. Yeah, and there's the title screen again. So I think the game is actually running. I'll just see. Coin it up. Okay, it flickers, and when I hit one player start, yeah, okay, it actually switches to this. This might actually even be part of the you know, of the live bars for player 1 and player 2, I think. Okay, so what we are getting here, let me just start it again, so make a little reset. So this is probably the test screen, we don't see anything here. This is the title screen, this is the double dragon, I think, symbols. Yeah, so what we are seeing is some text overlays or some graphical abnormalities that would correspond to the graphical overlays, but no background, no sprites, nothing at all. Okay, so let me show you something interesting I just figured out. If you remove actually this prompt chip over here on the CPU board, let me just pry it out. So if you take out this chip here and then look at the screen, you can see that there's the background and the game is running. Okay, now it's black again because I think this is the high score table. Okay, there's half of the title screen. Okay, let's just coin up the game and start it over again. Okay, so here's the background. Okay, so this chip removed, we can actually clearly see that the game is running. So, and if you're asking yourself now how I got to the idea of removing that particular chip, let me actually show you in the schematics what thoughts ran through my mind when I decided to remove this particular IC. Okay, so just before we get to the schematics, I just wanted to explain something which might be a bit trivial, but in the case of the Double Dragon board, and actually for most arcade boards, the graphics that you can actually see on the screen normally consist of several layers which are actually generated independently and have to be merged at some point in the circuitry to actually get the final data that has to be displayed on the screen. So there's a background layer, which in the case of the Double Dragon board contains the graphics of the streets, the houses, all background graphics, and that's what we actually just saw on the screen when I removed the chip. And parallel to that, there's also a screen being generated which contains the sprites, and in this case that's of course the players and the opponent sprites. And as a third instance, there's another screen generated which contains the text overlays, which is like the timer, the score, and the live bars here on the bottom of the screen. So, and all those three layers are put together in a certain hierarchy to get to the final image. And the hierarchy would of course be something like the sprites go in front of the background and the text overlays go in front of the sprites. So at some point in the schematics there has to be some circuitry which does actually make the decision which part of the graphics it will actually show on the screen for a certain pixel on the monitor. And it is going to check, okay, there's for this spot, for instance, there's some background graphics, and there's no sprites and no text overlays, so okay, I'm going to display the background graphics. And at another spot it's going to see, okay, there's background graphics, there's also a sprite, and there's no text, so at this spot I'm going to display the sprites and I'm not going to show the background. Because if it would, the background would go over the sprites and you wouldn't see the characters and opponents for this particular pixel. And at another spot there could be maybe some background, maybe also a sprite, but also a text overlay, so something like the live bar. And so there has to be, this time there has to be the decision that of course the text overlay will be going to the screen and sprites and background graphics are ignored for this particular spot, because the text overlay always has the highest priority. Okay, and now for the double dragon board, you can actually see that here. This seems to be quite confusing at first, but it actually is pretty clear what is happening here. So we have several data lines coming in here, and they are called bcol, I think ocol, and mcol. Let's ignore this AB for a moment. And I think the bcol is the background graphics actually. The ocol is supposed to be the object graphics, so that would be the sprites. And the mcol, I don't know what actually the M stands for, but that would be the text overlays. So, and those data lines are coming in here, and they are going into those chips which are multiplexers. So those chips actually have their outputs up here, and they can switch between those lines, those input lines here, with their data select lines, which are going into the chips right here. And those data select lines are coming from, as you can see, this PROM chip here. So this PROM chip actually decides by switching those lines, those two output lines, which one of the pixels is going to the screen and which one doesn't. And it does that on the basis of those inputs here. And again, those inputs are based on the data that is actually coming through the bus. So the PROM chip is looking at the data that is coming through each of the lines, and then is deciding which layer will actually be shown on the screen. Okay, and this certain PROM chip that is actually the decision maker for the displaying of the layers is the one that we actually just removed from the PCB. Yeah, that's why I wanted to remove it, because it has to do with you know, the hierarchy of the layers. And it occurred to me when we first looked at the screen, which was all white, and we saw some signs of the text overlays, it appeared as if this PROM chip maybe would only, and that's probably what it does, it would only display the text layer. Well, when we removed it, we already could see that another layer has been displayed, which was the background layer. And we can actually, by because when the chip is removed, those two lines are floating, by putting them to certain values with jumper wires, for instance, we will probably be able to select if there's the text layer being displayed, or the sprite layer, or the graphics layer. Maybe we'll just do that to take a look which layers are working and which layers are actually not working. Okay, so now as the PROM chip is removed, I actually connected two lines to pin 1 and pin 12 of IC74, which then puts out a signal which goes into the multiplexers. So, and you can see that here I got leg 1 and leg 12 here, and I pulled them high on these EEPROM chips. And if you pull both of these lines high, this is what you get. You get the background layer, and this is also what we saw when we removed the chip. The outputs of the PROM then were floating, of course, but they were probably interpreted by the board as being high all the time. So we get the same result here. So, but it probably will be getting interesting when we are grabbing one of those wires, removing it from the +5 and connecting it to a ground. We will then get the sprites. Haha. Okay, that is the sprite layer, which seems to be working fine actually. Okay, so now it's gone because it's probably the game just switched to the high score screen. Okay, we have the other part of the dragons now on the screen. Very interesting. So this is the sprite layer, and it seems to be fine also. Okay, here you can see the garage and the bad guys. Okay, so that's good. And well, probably if we put this back to a high state and switch the other one to a low state, we will probably get the text layer. Yeah, we do. And this looks like that. So that is obviously the problem. The text layer, this is the high score table again, the text layer seems to be non-working. Okay, so the next step would actually be to take out our beloved logic probe and actually look at this mcol bus, which should contain the graphical data for the background, which for the text overlays, which does not seem to be right, and figure out what is going wrong with this bus signal. Okay, so the signals for the text layer, mcol, are coming from page 4 of the Schematics 7a, and page 4 would be over here, and we can see that, here we go, that the mcol signal comes from IC53. And the data lines, which are 0 through 6, I suppose, are on pins 19, 16, 15, 12 and 5, 6, 9. So we should check those pins with the logic probe. Okay, I made myself a little cheat sheet here. These are the mcol, this should be the mcol signal on IC53. These are the legs. So first bit would be leg 19. IC53 is over here. So this would be 19. This appears to be high all the time. Next one would be 18, 17, 16, high all the time. 15, high all the time. 14, 13, 12, also high all the time. Then we got 4, 1, 2, 3, 4, which appears to be low, no, which is toggling, okay. 5 is toggling, and 9 is also toggling. So the lower 4 bits are actually high all the time. These 3
seem to be toggling.
Okay, and looking at the schematics again, we can see that the lower 4 bits are actually coming from another source than the upper 3 bits over here, interestingly. So the signals that are pulled high all the time are coming from IC 52. So I guess we should actually look at IC 52 and look and check the signals over there.
Okay, IC 52 is is this one over here, and the input lines for IC 52 are 3. The pins are 3, 4, 7 and 8, so we take a look at those. 1, 2, 3. Okay, this is floating. 4 is floating. 5 is high, 6 is high. 7 is floating. 8 is floating. Okay, that's the explanation. So there's no input. No input to IC 52, which was this one over here. So no signal probably coming from IC 51, which is a multiplexer, obviously. Okay, so now looking at the outputs of IC 51, which are legs 4. 1, 2, 3, 4. This one is floating. 5, 6, 7. This one is floating as well. 8, 9. Floating. 11. No, excuse me. 10, 11, 12. Floating. Okay. So obviously the outputs of this IC 51 multiplexer don't do anything, so I guess we will replace IC 51 and see what we get. Okay, and interestingly, looking back in the schematics at the PROM chip that we talked about earlier, the signal lines from the text overlays which are going into the PROM to make the decision which layer is actually shown for a certain pixel on the screen, the signal lines from the text layer are the lower 4 bits of the M-coil signal, which as we just saw, are pulled high all the time. They are sent to a NOR gate. So if those are high all the time, the NOR gate's output will be low all the time. Pin 3 as an input pin of the PROM will be pulled low all the time. We can actually just verify that on the board. Okay, so if we just look at the socket, we got high here, we got a toggling signal here, and pin 3 is, as expected, is low all the time. Okay. Okay, and as we can see here, pin 3 on the PROM is actually an address line. That's address line number 4. And this address line actually leads together with the other address lines from the other graphical layers, leads to a certain position in a table which is stored in the PROM, which then leads to a certain output at pin 11 and 12 that we saw here earlier, which then switches between the graphical layers. So, and if bit A4 is low all the time, what does that mean for the output of the PROM? Well, you can actually check that out if you look at the contents of the PROM chip. If you would address, this is the complete contents of the PROM chip, and you can see it's only 1s, 2s and 3s. So that's only, I think the 1 should be would be the text layer, the 2 should be the sprite layer, and the 3 should be the background layer. So, and if you now would, this is the address, if you now would take that address and pull the 4th bit low all the time, you would actually this line you would be okay. Then after you get to the address 10, that's the first address where A4 would be pulled high, you would get a 0 instead, and you would fall back, so to say, into the first line, and you would get 1s also. And after that you would get 1s, and for the next line you would also fall back to this line, and you would get, so no matter what, you would actually get an output of the text layer if A4 is low all the time. So that explains why we are only seeing the text layer, and it actually confirms or indicates that there's probably nothing wrong with the PROM chip at all, but it's just a problem with the inputs, which are caused by IC51, which we just saw, and which we should now replace. Okay, I just put the board on the bench, flipped it over, and now I see this. I was really shocked at first, but what I think happened here is somebody actually resoldered the whole board. Each and every connection of ICs and all the capacitors and anything have been resoldered by someone. And I was actually shocked because it looks quite messy, but luckily I think this is not due to any corrosion like the brown color of those areas, but it's just old solder flux that stayed on the board. And well, the board is, as we saw, actually mostly working, so I still have high hopes that we are able to fix it. But that's just well, very surprising. And of course this really doesn't make any sense. You can't just resolder the whole board in order to try to fix a problem like this on a logic board like this, because well, resoldering some dry solder joints may make sense in some circumstances, mostly if there's really a high current flowing through a certain solder joint, and it might even heat up, or if there's like a large through-hole part connected to a certain spot, and which might lead to mechanical stress, or maybe on some connectors which are soldered to the board, like on a monitor chassis. It might make sense to resolder some of the connections, but this certainly doesn't make any sense at all, and I just hope that the guy who did this didn't destroy much of the board while doing this. But well, let's get back to the problem we found and replace the bad IC. Okay, so I removed pin IC51 and I put a socket in, and I also put the PROM chip back, and well, the screen, as expected, didn't change much. We still got the old issue, but I got from a donor board a new flip-flop chip, and I'm gonna put it in like this. Ta-da! And here we go. It looks like that's actually everything is back to normal now. And I'd say we are considering the soldering rework we saw beneath the board. I think we are actually very lucky that everything is still working. Well, it's getting late, but well, just as I thought that we were finished, I actually hooked up the sound for the first time, and well, there's nothing much going on except a bit of noise. The amplifier sure is working. Well, so no music and no digital effects. The sound section is actually this part here on the CPU PCB. Well, I guess I'll put the PCB back on the bench and make a closer inspection of this part of the board.
Okay, looking actually at the not so nicely resoldered board, I just noticed this. There's actually two IC pins bridged over here. This is the first obvious problem that I saw when I looked at all those resoldered pins. So I guess I'm gonna remove that solder bridge and see if we get any further. Okay, so I hooked the board back up. Let's see what we get. So no humming sound, at least. Oh, okay, the music is back. Great. Okay, let's check the digital sounds. Oops. Okay, there's something wrong. So part of the sounds is working. I heard some digital sounds which were actually okay, like the opening of the garage. Oh, there you heard another sound. Well, yeah, okay. Turn that off. Okay, I think this board has basically some circuit parts for the music, which are located somewhat over here. There's a sound chip for the music, and this is the EEPROM, I think, for the music. And these EEPROMs are for digital sounds, and these EEPROMs are, there are two sound channels actually. So one sound channel seems to be non-working. Okay, so I guess I'll take a look at the schematics, and then maybe with a logic probe I'll poke around and see which one of the circuits is working and which one isn't. Okay, just poking around with the logic probe, I just noticed that this EEPROM has some activity on the data lines, as you can see here, which is good. And it's also only happening when it's playing a sound. As you can see, it stops right now. And this EEPROM over here, which is for the other channel, which is probably not working, somehow has floating outputs. So I think floating outputs can actually only mean that this EEPROM chip is actually bad, so I think I'll just burn a new one, and if we're lucky, the sounds should be back on the second audio channel. Okay, I just programmed a new chip. So let's put it in and see how we go. Okay. Okay, music is good. I'm just gonna start a game here. Okay, great. So it looks like the sound effects, the digital effects are back again. So I think finally this repair is finished. Okay, so I thank you for watching my video, and if you have any questions or comments, please leave them on the bottom of the video. I'll try to answer all your questions. If you like the video, of course feel free to subscribe to my YouTube channel. I plan to do more arcade repair videos in the future. So again, thanks a lot.